In the problem here, we're asked to find the probability that this component is going to fail in under 100 hours. And if we just assumed, without checking, that the time that a component would fail, we just assumed it was a normal distribution, and we went in to our probability distribution plot and got the answer. Let's see what would happen. Okay, I'm dealing with a normal distribution, and in my raw data, which are right up here, my mean is showing as 231.2 with a standard deviation of 308.2, which, by the way, tells me there's something weird about these data, because when the standard deviation is way bigger than the mean, it's generally an indication that the data do not follow a normal distribution. All right, I'm assuming the distribution's normal. I go to shaded area, I plug in my x value, and I want it to know what's the probability the component fails in less than, which is why I'm asking for a left tail, less than 100 hours. And I get an answer of 0.3352, so a 33.52% chance. But this answer, however, is not correct, because as we've seen from the histogram and the box plot, these data don't follow a normal distribution. All right, let's assume then that we had checked. We figured out by logging the data it makes them more normal, and we get our answer using these data instead, which actually is the more correct way. So if I go back to my probability distribution plot, and this time I have to use, oh, hang on now, I got to jump up here because I need to find, okay, here's the natural log of the data, and I need the mean and the standard deviation. All right, so let's plug this in again. I need a mean this time for the log data is 4.722 with a standard deviation of 1.278. Okay, go to shaded area. But this time we got to be careful now, because there's no point using the number 100. Because we've logged the data, we actually have to use the natural log of 100. And if you plug that in your calculator is going to give you an answer of 4.605. Okay, I want the area to the left. And this time I get an answer of 0.4635. So using the raw data, there's a 33% chance of this happening. But if I use the log data, there's a 46% chance of this happening. So there's a big discrepancy in these answers. This answer is the more correct answer, because we know these data follow what's referred to as a log normal distribution. They're normal after they're logged. Now, another way I could have done this, coming back into this probability distribution plot, you can choose different distributions, and there is a log normal distribution here, but you still have to input the mean and the standard deviation, which I got to jump up here again now because there's no way I remember that. Okay, hitting my last dialog box, I'm using the log normal. And when it asks you for location, it's actually asking you for the mean of the distribution. And the mean of the log data is 4.722, and scale refers to the standard deviation, which for these log data is 1.278. Threshold you leave alone. All right, I go into my shaded area. I'm looking for the area in the left tail, and I'm plugging in my original value of 100. And if I say OK to this, notice how this plot looks, well, not completely different, but different. And that's because this is the standard way a log normal distribution looks. It doesn't have that bell-shaped curve. But the area to the left of 100, from 100 back to 0, that area is 0.4636. So this is the same answer we got when we use the normal distribution, but we use the log data in order to get the answer. And you can do it either this way or the previous way. You might find the previous way a little bit less confusing, to be honest.